This is Higher 1, Chapter 1. In this chapter, we're going to be covering different types of numbers, factors and multiples, understanding cubes and squares, BIDMAS, prime factorization, and how to work out HCF and LCM and understand where it is to be used. Now we have natural numbers. Natural numbers are numbers that occur naturally in, well, of course, nature. So you could have one of something like one tree, two trees, or 4 bananas. They occur naturally. Then you have whole numbers. Whole numbers are all natural numbers and 0 inclusive. And then we have negative integers and integers. Now integers is inclusive of every negative number and every whole number. And negative integers, as you know, is just negative numbers, the counterparts to natural numbers. And now we have prime numbers. A prime number is a number which only has 2 factors, 1 and itself. Now 2 is the only prime number which is even, as it only has 2 factors, 1 and 2. Every other prime number here is odd, 3, 5, 7, 11, 13, 17, and so on. But that doesn't mean that every odd number is a prime number, such as 25. It's a number that ends in 5, so it means we know it's in the 5 times table, so clearly it has more than 2 factors. So any number that ends in a 5 can't be a prime number either, because it indicates it's a multiple of 5. So, with its absence from every timetable, it is an indication that it could possibly be a prime number. Now there's such numbers as 51. It's quite difficult to see if it's a prime number or not, but how can we check? By doing a simple calculation, such as 5 plus 1. Because we have the number 51, don't we? You add the digits. So when you do 5 plus 1, that gives us 6. Now when you add the digits of a number, and the result you get is a multiple of 3, it means that the initial number we started with is a multiple of 3. So 51 is in the 3 times table, so it's not a prime number. Exercise 1.1, question 1. Write down all the prime numbers between 50 and 60. Now, to do this question, it'll be easier for us to list all the numbers between 50 and 60 and narrow it down. But we already know beforehand that no even number other than 2 is a prime number. So that makes it easier for us. So we have numbers like 51. We have numbers like 53. Now 55, I could write it down, but it's not possible for it to be a prime number, because it ends in a 5, so it's a multiple of 5. So we have 57, and you have 59. Now we're going to narrow it down further. Now we need to check if any of these numbers are multiples of 3. Now 51, if I did 5 plus 1, I get 6. That means that 51 is a multiple of 3. Now if I did 5 plus 3, I get 8, not a multiple of 3, so it's not in the 3 times table. So 5 plus 7 is 12, and 12 is a multiple of 3, so therefore 57 is not a prime. 5 plus 9, that's going to give me 14. 14 is not a multiple of 3, not in the 3 times table. So my final solution is going to be 53 and 59. Now we have question 2. Write down all the factors of each of the following. So we're going to do 2 of these questions. Question 1, 16. Now what I like to do is make a little grid. So I underline it, make a grid. So I can write down the first pair that make 16. So 1 time first pair would of course be 1 and the number we're starting with, because 1 times 16 would give me 16. I know it's a multiple of 2, so we can move on to 2. So 2 times 8 gives me 16. Now 3 times nothing gives me 16, so 3 is not a multiple. Then we have 4 times 4. That's going to give me 16. So now we can't move on to 8 because we already have 8. And we're just going to be repeating a pair. So we're done. What we're going to do is that we're going to list all the numbers in a U shape, like this. So we're going to write 1, 2, 4, 8, and 16. Question 3. Write down the first 5 multiples of each of the following numbers. Now the first 5 multiples of 9 is going to be the first 5 numbers in the 9 times table. So we have 9, 18, 27, 36, and 45. It's as simple as that. Exercise 1.2. Now here we're working at the square, square root, cube, and cube root of various numbers. Now 9 square means what? 9 times 9. So 9 times itself, which is going to give me 81. So 81 is a square number. Now we have minus 9 times minus 9. Now as there's a bracket and a minus sign is included inside the bracket, so it means it's repeating with the 9. So we're going to minus 9 times minus 9. Now if we had minus 9 square, that square will only apply to the 9 but not the minus. So here we're going to have 81 again. As when you do a negative number times a negative number, the outcome will always be positive. Now the next question is minus 5 cubed. Now remember, the cube does not apply to the minus here. So it's going to be minus here, and you're going to have 5 times 5 times 5. And that's going to give me minus 125. Now here the minus sign is inclusive. So you're going to have minus 4 times minus 4 times minus 4. Now minus 4 times minus 4 is going to give me 16. Now 16 times minus 4 is going to give me a negative answer, and that's going to be negative 64. Now the square root of any number. Now square root means that what number times itself gives you 49. What number times itself gives you 64. Now I know that 7 times 7 gives me 49. But I also know that minus 7 times minus 7 is 49. So when you work at the square root of something, it could possibly be the positive or the negative. So we don't really know which one it's going to be, so we're going to write a plus, minus like this, and then a 7. Now the square root of 64 is going to give me, we know that 8 times 8 is 64, minus 8 times minus 8 is also 64, so our solution is going to be minus plus minus 8. Now the cube root means what number times itself 3 times gives you 343. Now you should be familiar with all the cube numbers or be able to recognize them. Now the cube root of 343 is going to be 7. Now here, we're doing the square root of 100 times 3 squared. Now the square root of 100, when we're doing an equation, we will take just the positive value. So the square root of 100 is going to be 10, and we're going to multiply it by 9. Our solution is 90. Now the cube root of minus 125. Now the cube root of a negative number will always give me a negative answer. So our solution is going to be minus 5. Now here, we're going to have minus 2 plus 9, and that's going to give us 7. 4 cubed is going to give me 64, times the square root of 100 is 10, over square root of 64, 8. Now, we can work out this by simply putting 64 over 1, and you can simplify numerator with a denominator. So I can divide this denominator by 8, I get 1. I can divide this numerator by 8 as well, and I get 8. 8 times 10 is 80. Now 4 squared is 16, and then we have the minus. Now the cube root of minus 8 is going to give me minus 2. We're going to divide the whole thing by the square root of 4, which is 2. Now minus and minus, when they're together like this, it makes a plus. So we're going to have 16 plus 2 over 2, which is 18 over 2, which equals to 9. Now we're working on BIDMAS. BIDMAS is brackets, indices, division, multiplication, addition, and subtraction. Now the number one priority will always be given to the brackets, what's inside the brackets. And then we focus on indices, and division and multiplication have the same priority. One is not more important than the other. So when you have both division and multiplication, you will do it in the order it is written in. For example, 8 times 4 divided by 2. You would do it in the order it's written in. The same rule applies to addition and subtraction. So if you had 9 minus 7 plus 2, you should do it in the order it is written in. And when you're doing BIDMAS, you can pair them up to make it easier for yourself. Now here we have multiplication and division. Now the sign on the left of the number belongs to the number. So here we have plus 4 times 5. So we're going to multiply these two. Then you have minus 12 divided by 2. So you're going to divide these two. So because you can pair them up, you can work them out at the same time. So you can do 9 plus 4 times 5 is going to give me 20. Then minus 12 divided by 2 is going to give me minus 6. Now 9 plus 20 is 29. Minus 6 is going to give me 23. Now here you can do the same thing. Now BIDMAS means you start with the brackets, and the other rules from indices all the way to subtraction will apply inside the brackets now. Now because we have a set of brackets here in question D and another bracket inside, it means that we're going to prioritize the 15 minus 5. Once we do that, then you're going to do whatever you get from 15 minus 5 times it by 4. And the same will apply here. And 15 minus 5 is going to give us 10, then times 4. This is the first bracket, divided by 5 times 2. So we're going to get 40 divided by 10, which will give us 4. Express the following numbers as products of their prime factors. Now, question 1a, we have 120. So what we're going to do, we're going to break it down into prime numbers. Now, to do that, we can break it directly into small numbers, like 6 and 20. Or you can move directly to prime numbers to make it simpler. So we can see it's an even number, so we can break it into 2 and 60. We can break 60 down further into 2 and 30. 30 can be broken down into 3 and 10, which can be broken down into 2 and 5. Now, these are all prime numbers. So 120 can be written as, we have 3 2's, so we're going to have 2 cubed times 3 times 5. Next we have 315. Now 315, we can see ends in a 5, so it's a multiple of 5. So we can break it into 5 and, what would that be? So 5 goes into 3 0 times, into 31, 6 times. And then carry the 1, 15, 3 times. So we're going to have 63. So 63 can be broken down further into 9 and 7. And 9 can be broken further down into 3 and 3. Now these are all prime numbers we're left with. So 315 will equal to 3 squared times 5 times 7. So this question is saying that 40 can be written as 2 to the power of m times n. Now that simply means write 40 as a product of its primes. So 40 can be broken down into 2, 20, 2, and 10, 2, and 5. 2, 2, 2 prime numbers, 5 is also a prime. So 40 will equal to 2 cubed times 5. Now we're going to match it to what's written in the question. Now 2 to the power of m. So m will clearly be 3 and n will be 5. So we can fill in the spaces here now. Now we're working through HCF and LCM. Now HCF means highest common factor. Now the highest common factor is a highest factor that is common for 2 or more given numbers. The lowest common multiple is the smallest possible number that can be divided by 2 or more given numbers. Now the method for working out HCF and LCM is very similar. There's only one distinction between the two, and we're going to see that in the second question here. Now the first one, fairly simple. Let's start by writing the two numbers, 225 and 75. Now we're going to make a grid. Now what number can go into both of them? Now you can think of the biggest possible number, or you can start with a small number like 5. But if you can notice a bigger number, such as 25, that's fine as well. So if I wrote 25 here, you could divide it and you would still get the same outcome. But let's start with something smaller. Let's start with 5. And when I divide it by 5, I'm going to get 45 and 15 here. Now both numbers are still divisible by 5. So I'm going to divide by 5 again. We're going to get 9 and 3. Now we can still divide them both by a common number, and that number is going to be 3. We're going to get 3 and 1. Now the HCF is going to be every single number in this column here multiplied. So we're going to have 5 times 5 times 3, and that's going to give us 75. So the HCF will equal to 75. Now the LCM is going to be these numbers here. It's going to be in the L shape. So you're going to multiply 5 by 5 by 3 by 3 again. And that's going to give me 225. Now the next question is asking us to work out the HCF and LCM of 3 numbers here. So we're going to have 26 here, 39 and 52. Now we need to find a number that we can divide all 3 numbers by. Now for this one, it's not going to be very obvious, as the number we can divide them by is going to be 13. So we're going to divide by 13 on the column here. And we're going to get 2, 3, and 4. Now there's no common number I can divide them all by, so we're going to end the process here. So the HCF is just going to be the column on the left, which is just 13. Now LCM, we can use the same grid we use for HCF to work at LCM, but there's one distinction. Now the last row where we have 2, 3, and 4, there can be no common factors. There can't be any common factor between the numbers. Every number has to be distinct. So 2 and 4 are not distinct, as they're both multiples of 2. They can both be divided by 2 then. So we're going to continue the process for LCM. So we're going to divide it by 2, and we're going to get 1, 3, and 2. Now all the numbers are distinct in the last row. 1, 3, and 2. Nothing is common, so we're going to multiply in an L shape. So we're going to have 13 times 2 times 3 times 2. And this is going to give us 156. Question 2. 2 lighthouses can be seen from the top of a hill. The first flashes once every 6 seconds and the other flashes once every 15 seconds. If they flash simultaneously, how long is it until they flash again at the same time? So here, you can imagine the first lighthouse is going to be flashing after every 6 seconds, and the next one after every 15. So the time is going to be increasing. So we're going to see where the two numbers meet. So this means we're going to be using LCM. So we're going to write down here 6 and 15. And now what number can you divide them both by? 3. That's going to give me 2 and 5. And you multiply in the L shape. So the LCM is going to equal to 3 times 2 times 5, which is 30 seconds. So after every 30 seconds, they're going to be flashing at the same time. Now we're going to work through question 4. Question 4 is a fairly long question, but fairly simple. Martin is organizing a summer fair. He needs bread buns and burgers for the barbecue. Now ideally when you have a barbecue, you don't want to have extra buns or extra burgers. You want to have the same amount. So if each pack of bread buns comes in 40 and each pack of burgers comes in 24, we want to find where these two numbers eventually meet. So we're going to be working out the LCM. So the LCM here is going to be worked out by writing 40, 24. Now the number we can divide them both by is going to be 4. 40 will become 10, 24 will become 6. Now we can divide by 2. We're going to get 5 and 3. Now to work at the LCM, you times in an L shape. So we're going to do 4 times 2 times 5 times 3, which is going to give us 120. As 4 times 2 is 8, 8 times 5 is 40, and 40 times 3 is 120. Now we want to work out how many packs we need to buy. Now that we have the total number of, buns and burgers that we want to buy is 120, but we need to work out how many packs of bread buns and burgers. Now to do that, all you have to do is get the LCM, which is 120, divided by 40, which gives us 3. Then you can do 120 divided by 24, and that's going to give us 5. So you're going to have 3 packs of bread buns and 5 packs of burgers. Now, question 5. James thinks of two numbers. He says the highest common factor of my two numbers is 3. Okay, and the lowest common multiple of my two numbers is 45. So what we need to do here is make the same grid we used before for LCM and HCF. So we got a number here, and we got a number here. Let's call this number X and this one Y, because we're trying to work them out. Now when I divide both these numbers by 3, I'm going to get an outcome here and one here. And when I times all the 3 numbers together, I should be getting 45, as that's how you work at the LCM. So LCM will equal to 3 times 2 numbers, and that equals to 45. Now, I know 3 times 15 is 45, and what two numbers multiply together to give us 15? 3 and 5. So we're going to write 3 and 5 here. Now to get the 3 and the 5, we had to divide X and Y both by 3. So it means X would equal to 3 times 3, and Y will equal to 3 times 5. So 9 and 15 are the two numbers that James thinks of. Now question number 6a and 6b. Now two numbers X and Y have been broken down fully into the prime factors. Now to work at the HCF and LCM, what we need to do is that we need to look at what's common. For HCF, we can see that 2 is common in both numbers, X and Y. But when you see two numbers that are common, you want to select the one with the smallest power. For HCF here, we're going to select 2, not 2 squared. Now we have X and Y have 3 in common, so we're going to select 3, the one with the smallest power. So 2 times 3 is going to give me 6. And then we have LCM. LCM is similar. So when you see two numbers that are common, you want to select the one with the highest power. So if we have 2 in both numbers, we're going to select 2 squared. We have 3 in both of them, so we're going to select 3 squared. Now 5 and 7 are extra numbers. So what we're going to do, we're going to bring them over as well. So you're going to times it by 5 and you're going to times it by 7. You bring the extras always only for LCM, not HCF. Now this question, you have two numbers 8, 6 and 5. And we have 3 numbers that we want to find the equal number of buttons to. So you want to find the LCM of 6, 5 and 8. So it's very similar to the question we did before with the bread buns and the burgers. So we're going to write 8, 6 and 5. Well, of course they shouldn't be so close together, otherwise it looks like 865. Now what number can go into all 3 numbers? No number. So we need to make sure all the numbers are distinct. 8 and 6 have 2 in common. So we're going to divide the whole thing by 2. So we're going to get 4 and 3. Now 5 can't be divided by 2, so we're going to leave it as 5. Now no number is common between the last row, so we're going to multiply this in L shape. So the LCM is going to equal to 2 times 4 times 3 times 5. And that's going to give me 120. So we're going to do 120 divided by 8, 120 divided by 6, and 120 divided by 5. And that's going to give me, so 120 divided by 8 is 15, 120 divided by 6 is 20, and 120 divided by 5 is 24. And that is the end of chapter 1.